Okay, we're starting chapter 4, and in chapter 4 we're starting with the triangle sum theorem, and we're going to be able to classify triangles by their sides and angles. We're going to be able to use the triangle sum theorem, which means that all triangles add to 180, which should be familiar to most of you. And we're going to use the exterior angle theorem to determine the measurements. So that one is going to be the big thing that's actually new in this section. We'll start off with a vocabulary. A triangle is a three-sided polygon. Three-sided polygon. We've already talked about polygons in general. We're going to get really specific. And so when we name a triangle, we're going to name it by its three vertices. So for example, we have triangle EGF. We could also name this as triangle EFG. Could also actually name this as triangle GFE. All of these, and there's more, are going to be the equivalent as long as you're naming the three vertices of the triangle. You can name it. We would have sides. Some sides on here. We'd have EG. That would be one side, and it's a line segment. We would have line segment GF. That is another side. And then we'd have line segment FE. So those would be the three sides of this. And then the vertices are the corners. The vert so in this case, E, point G, and F are the vertices, and so those are the corners. So that's naming triangles. We can classify triangles, and hopefully you've seen this before. We can have classification by sides, so that's specifically to looking at the sides. We have a scaling triangle, which means that we have three different side lengths, meaning nothing is the same. So that would look something like this. So we have a short one, a longer one, and then a third one that's still longer yet. None of them the same. We have isosceles, which means we have two sides are equal. Two sides are the same. So as a picture, we have something like this. Two of the sides are the same. That would be isosceles. And equilateral. Familiar with this term? Equilateral. All three sides. All three sides are the same. Okay, so as a picture, we'd have something like this, and all three would be the same. Okay, so that's classifying by sides. We can also classify by angles. Again, this should be somewhat familiar. An acute triangle means all three angles are acute, meaning less than 90 degrees. As a picture, we could have something like this. All of them are less than 90. I can make that a little clearer, so let's actually do that. Here, let's make it really clear that all of them are less than 90. We can have a right triangle, which means that one angle equals 90 degrees. Obviously, we can only have one 90-degree angle inside of a triangle. I'll probably ask you to explain why at some point. An obtuse triangle is going to have one more than 90 degrees. Okay, so here we set it up, and that is our obtuse angle. So again, I'll probably have you explain why does an obtuse triangle only able to ever have one angle more than 90. So I'll think about what that might mean. And then we have equiangular. Again, we're familiar with this. It means all the angles are the same. So all the angles are equal. And so an equiangular triangle, we're going to have all of our angles be the same. Okay, so that's classification, classifying by sides and angles. We'll take a look at interior and exterior angles. Again, this we've done a little bit with polygons on this before. We'll look at it again now. Interior angles are the angles inside of the triangle, so inside the polygon. So in this case, we'd have angle 2, angle 5, and angle 8. Exterior angles come when we extend one of the sides. So example, if we take angle 2 here, we extend that side. An exterior angle would be angle 1. This angle right here. Angle 1 would work. We would have angle 7 and then angle 4. Now we can also extend the sides going the other way, which is why we have more of these listed. We also have angle 3. We can extend out and go the other way, angle 6, and we can look at angle 9. So all 6 of those are considered exterior angles. We already know that an exterior angle is going to make 180 with the interior angle, right? And we also talked about the exterior angle theorem, which said, or the exterior angles all add up to 360. So those are things that we've done before. So if we were to take 1, 7, and 4, add those together, they would have to equal 360. If we took 3, 6, and 9, added those together, they would have to equal 360. Okay? So, moving on from that, just naming our exterior angles, we have the triangle sum theorem, which says that in a triangle, the interior angles are going to add to 180 degrees. So, for our picture up here, that means that angle 2, the measure of angle 2, plus the measure of angle 8, plus the measure of angle 5 are going to equal 180 degrees. And we could obviously use that to solve problems. Exterior angle theorem. In a triangle, the measure of the exterior angles is equal to the sum of the two interior angles not with the exterior, also known as remote interior. So let's take a look at this. So we have our exterior angle here. So that's our exterior angle. And our interior angles, are angles 1, angle 2, and angle 3. Those are the 3 interior angles. And what we're saying is that the exterior angle, in this case, angle 4, is going to equal the 2 angles that are not touching. So this is adjacent, so we don't want that one. We want the 2 that are not adjacent. So not adjacent, meaning 1 and 2 in this case. So this angle and this angle are going to add together to give you this. So as we write this equation, angle 4 is going to equal angle 1 plus angle 2. These 2 angles are sometimes called remote interior because they're far away and you'd need a remote control to be able to touch them. Kidding, but remote literally meaning at a distance. So these are at a distance away from 4. Let's keep on moving. Let's look at an example of that. So if I want to find the measure of MNO, so MNO is right here, MNO, so that's the exterior angle. I want to know what that's going to be. We can use what we just said, which was the exterior angle theorem, which says that this MNO, the exterior angle, is going to equal the 2 remote interior. So an interior plus an interior. So the exterior angle, we know, is 2x minus 5. The interior angle here is x, and the second interior angle is 70. We're adding those together. So once we have an equation, we can set this up and solve for x. We can subtract x from here, subtract x from here, and add 5, which is going to give us x equals 75. We now know what x is. We need to finish this off and find what the angle of MNO, which we know was 2x minus 5. So we will plug in that 75, and we'll get that we have MNO equals 145 degrees. That's it for the notes here. Again, our goal was to be able to classify triangles by their sides and angles. We want to be able to use the triangle sum theorem to determine the measurements in triangles. Again, triangles add up to 180. And then use the exterior angle theorem to determine an angle measurement, which again specifies that the exterior angle equals the 2 remote interior angles. Thank you. I'll see you guys soon.